The following program is brought to you by Element 14, the electronics community where you can connect and collaborate with top engineers from around the world. Join now at element14.com/presents.
Here at Element 14 Presents, we do what we must because we can. And one thing I can do is make very basic animatronics. So in my ongoing quest to bring all of the robotic characters that I love to life, I'm going to be making GLaDOS. That's right, everyone's favorite passive-aggressive AI from the Portal franchise. Let's jump in.
Amazing hacks. Inspired designs. Each week, Element 14 Presents brings you innovative projects using electronics, engineering, and more.
So what do I actually mean when I say make GLaDOS? I don't exactly have the industrial warehouse space that I think would be necessary for a full-size build. I've just got some folding tables and, well, my computer desk. But that's the start, and that's more than enough workspace for me to make a scaled version. And in this case, I'm actually just going to focus on her headpiece because that's where all the emotive parts of her really are. And at half scale, she's still pretty big. So here's how I did it. So let's take a look at this photo of GLaDOS. Now, she's meant to be a character from a video game. She's not based on any sort of robot in real life, so there's no proportions that we can immediately draw from. But one little detail that I'm very confident is something from our real world is this, a single red LED. And with that in mind, if I use a 5mm LED, we can define the rest of her proportions based off that. So I want GLaDOS to do three main things. Number one, I want her to light up. For that, I'm just going to use two regular 5mm LEDs. Of course, the one red indicator LED that I mentioned in the beginning, as well as one high brightness white LED, which I'll put behind some yellow plastic to diffuse for her eye. For her main processor, I'm going to be using a Raspberry Pi 3 because the second thing I want her to be able to do is speak. And for that, I need something that can play back audio clips and some advanced way to trigger them because there's going to be a lot of audio clips. Now, the Raspberry Pi doesn't have great built-in audio, so I'm going to be using an external I2S DAC. This is a really nice high quality one from Pimeroni that I really like using. And I've also got an amplifier attached to that. So this is a really simple solution for audio that doesn't take up a lot of GPIO. Now, of course, the amplifier needs to connect to speakers. So I'm going to be using two 4-ohm 10-watt speakers, which are totally overkill, and the amplifier isn't a 10-watt amplifier. But these will go in her ear things because that just seemed like the most logical place to put two speakers, and that is how she will be able to speak. Last but not least, I want her to move, so in order to make her move, I'm going to be using two servo motors. This one just has some extra bracing that I've had for a while. Now, the Raspberry Pi does have the ability to do PWM via its GPIO, but it's not real time and it kind of sucks. So it's not great for servos directly. So I'm gonna be using this PWM breakout board, which gives me 16 ports for some high quality pulse width action. And this will be really simple to control and will also allow me to control the LEDs, which will be nice and simple, and I won't have to worry about limiting the current. Now, everything needs to be powered. So I've also got this 50-watt power supply. And this, of course, is an AC to DC power supply. So I've got this nice little switched power entry module, and this will just connect to the AC/DC power supply, and we will connect the 5-volt output of that to the motor driver and the Raspberry Pi. It would be ideal if they were separate on separate rails, but this will be fine for now. All right, so first things first, let's talk about the electrical design of GLaDOS and how everything connects. At the heart, we've got the Raspberry Pi. Let's give that a nice little box. That's exactly what it looks like in the real world. And we've also got the amplifier, just amp, and that connects via I2S. And then we've also got our two speakers, SPK, SPK, and of course those connect directly to the amplifier, and via I2C we have the PWM board, and this will control the servos. So serve 1 and serve 2. So those are the two main motors. So let's do that. We'll also have the LEDs driven via the PWM board too, just to keep things nice and tidy. I could have drawn the symbol for an LED, but I'm just gonna draw blocks for everything. It's block diagram. Those are actually all of the main connections for the electrical side of things. I guess we've also got the power supply. So we've got our AC, DC power supply, and this of course is our 50-watt power supply. So this will provide 5 volts via a connector, and this will allow us to detach everything so I can mount her somewhere else. But this will just be our 5 volts, 10 amp power supply. On the whole, fairly simple, and there's still a lot to do to put all of this together. So let me go assemble it and we will test it out. All right, so let's talk about the broad strokes of the 3D design, because I could totally talk about the 3D model for an entire episode, but this is only part of it, and you'll see more of these pieces in the real world soon. So I modified her design to be arranged around a central support axis, and this consists of an aluminum hub plate and 6 spokes on each side. These hubs are held together by 2 1/4-inch thick crossbars and are compressed together by some threaded rod. The spokes serve to support the main white outer shell, which in turn provides support for the side plates and their accompanying bits and bobs. Her eye mechanism is driven by 2 servos, the first of which mounts to one of the main crossbars, while the other mounts to a bracket that couples it to the first servo. This way, her yellow pupil light and eyelid mechanism all move as one unit. Her eye can slide in and out of her faceplate in the game, and while I consider this mechanism for this build, it will take a major rework and simplification to make the mechanism practical. Her headbands just mount directly to the side of the plates, but they don't really do anything, nor would they in-game. Technically, her head doesn't actually tilt down as much as you think. It's actually some crazy, elaborate, belt-driven, curved track mechanism that slides her whole faceplate and internal mechanism around. While that's cool, I'm not sure how functionally possible it is, and it would make her much more expensive and difficult to assemble. So I've made my own version of her that is somewhat more sensible. All right, so as you can see, there are a lot of pieces that go into this. And of course, last but not least, I've got her head pieces, which are pretty big. And I'm mostly happy with how they turned out. While structurally, they're what I want, this is the first time that I've ever worked with fiberglass. And I probably should have gotten some experience on a smaller piece first, but for whatever reason, it's delaminating from the underlying 3D print. So there are all these little bubbly bits over the headpiece that are driving me insane. And at first I cut some of them out and refilled them and sanded them and repainted them several times, but it keeps delaminating. So it's kind of a lost cause at this point, and no amount of sanding and filling is really gonna fix these pieces. So ultimately, I'll have to make entirely new head plates, but that's not gonna happen for this build because that's at least 90 hours of printing, 2 more kilograms of filament, plus all the sanding and painting to make this look okay. The next major step that I need to figure out is calibrating her eye mechanism. So let's go in for a close-up so I can explain this a bit more in detail. All right, so to get a better understanding of how the mechanism is supposed to work, let's take a look at the pieces that are actually supposed to move. So at the innermost level, we've got these two components that act kind of like eyelids, and these move up and down. And they move up and down inside this piece, which is another component of her eye mechanism. And this piece moves up and down inside of this piece, which I don't really have a good name for, but this piece is fixed to her faceplate. And then this whole assembly move as one, and then these can move in and out inside of this piece. So let me grab the mechanism itself. I've got the innermost servo right here, and this is what will actuate these two pieces up and down. There are some couplers that attach to the plates behind this so that that actually moves properly. And in addition to this, we've got this main supporting bracket, which attaches to the larger piece so that everything moves as one unit. It's a little awkward to see now, but it'll make more sense when I actually put it together. Now, one thing I do need to figure out, of course, is I've assembled this just to see that everything fits, but I need to center these servos because I don't actually know that they're in the right position, nor do I know the actual pulse widths that will correspond to the right amount of open and close for the eyelids or the maximum travel, and same with the tilting of her entire eye assembly. So I'm going to set up a simple way to test that out and figure out how exactly these need to be positioned at the start. So I have to take this apart. Well, I'm going to test these, and then I'm going to take it apart, and then it'll be calibrated, and it should be able to move within the proper constraints. All right, so in order to test everything out, I need to first set the servos to their center point. I can't find my servo tester, but what I do have is a TCLC microcontroller, as well as a 10K potentiometer. And with this, I can play with the servo positions. And right now, the LED is lit up. I have it programmed so that when it's at 90 degrees, it will be on. And that way I can just play around and get back to the center point if I want to leave it there, which I'm pretty sure I want to do. And then once they're both at their center points, then I can go through and actually figure out the max pulse width that corresponds to the actual real world amount of travel that I want these servos to have so that they don't crash into anything. All right, so now I've got everything hooked up for this servo right here. And if I fiddle with the potentiometer, you can, of course, move it back and forth, which is what it should do. But as you can see, the center point, like right here, is way too tilted. So I need to pop this off and rotate it so that it's closer to the position that I actually need it to be. And I'll need to do the same thing for this guy right here. But wait, you might be wondering, you're just tilting this back to some random angle. How is that calibrating it at all? And you'd be right. What I really need to do is just get it close to the center point, because I will actually need to calibrate it in software. As long as this has enough range of motion from the center point, which both of them will, they really only need to travel at most 45 degrees in either direction. So that's more than enough leeway to get this a little inaccurate right here. So I'll need to do that in code, but for right now, as long as I get them mechanically close to the center, that will be good enough. All right, so before I begin the servo testing, we'll of course need the full power supply because I'll need to power both servos simultaneously, as well as the Raspberry Pi. So I've got my 50-watt power supply mounted to this circular base plate, just some rubber feet on the bottom so it doesn't slide around. This is all going to go inside of this overly large aluminum scrap tube that I got at the metal shop for like $1. And this will, of course, house the circular connector for the DC power supply that will run up via cable to her head, as well as the power entry module. So I just need to connect this to the power supply, and I've got an extra wire for ground because this is a giant metal enclosure that will have high voltage AC running through it. So I need to make sure I don't electrocute myself. That would be nice. All right, so here we are over at my desk. I've got just some things pre-assembled so that we can test out the motion of the eye components. So you can see the 3D printed eyepieces right there, and these connect, of course, to the servo mechanism that I showed earlier. I've just got the bare minimum aluminum frame so that everything is structurally sound while I test it. And if I can do this one-handed, I'll flip this around. You can see the Raspberry Pi. We've got the amplifier and the PWM breakout board. So we've just got those servos connected to the first couple of channels. And of course, all of our power connections to the DAC breakout board right there. And then here are the power cables coming from the power supply right there. So I'm gonna set this back down carefully, and I can do a little coding, and we should be able to get her eyepiece to move the way that I expect, and nothing will break. All right, so I've scribbled some words onto a notepad, and when I hit go, they do something. So let me run the program, and we should be able to tilt her main eye mechanism up and down. And pupil, the pupil has very limited range of motion, just about 10 degrees total, but I'm happy with how responsive it is. Although for some reason the servo does respond fairly slow when run off the PWM driver compared to when I tested it earlier with the just the potentiometer and the knob. I don't know if that's just my own perception or if I don't have the full pulse range correct, but that's what I want. All right, so now I'm going to put it all together, and we should have ourselves an evil robot. Say hello to my passive-aggressive, artificially intelligent friend. Ah, isn't she beautiful? I think she's beautiful. She's also very heavy. She weighs 10, 12 pounds maybe, and is very awkward to hold, which is why I made this handy-dandy grip. Oh man. I'm so tired of this project. I love it, but I'm so tired of it too. All right, let's see if we're back in business. All right, lifting her up, switching on the power. Eye is good, and just gotta wait for everything to boot up. We should see the servos move and the red indicator light turn on. Come on. Rather than wasting more hours of my life getting the script to run at boot, I'm just gonna have it run, because that's the more interesting part than watching me type commands into a computer. So I've got her running attached to my desktop. So let's see, should still be able to move her eye up and down. Now I don't have any limits for the main eye mechanism, or at least the larger one. The pupil is the one that I'm more concerned because, or the eyelids, because that one is much more likely to damage itself. So it still has a little trouble, but for the most part, I am satisfied with that range of motion. All right, but wiggling a couple servos isn't as interesting as hearing her speak.
Surprise.
All right, so let's go through some of the more popular voice clips that people will recognize. So let's go with...
Oh, it's you. It's been a long time. How have you been? I've been really busy being dead. You know, after you murdered me. Okay, look, we both said a lot of things that you're going to regret. But I think we can put our differences behind us. For science, you monster.
Now, I've got about 50 different voice clips, so I'm not going to go through all of them. Maybe I could have them triggered by something going off in my house. I don't know. There's a lot of potential for this. I did include some extra bonus features if I ever, need a little self-esteem boost. Slow clap processor, still fully functional. She's not perfect, but she's pretty darn close. I'm super satisfied with my GLaDOS build. I definitely still want to give her a new faceplate, and I want to learn more about fiberglassing so I can do this right. But in the meantime, I think she turned out pretty cool. If you guys have an idea for something I should do with her, I did put a Raspberry Pi in there for a reason so I could extend her functionality, and really there's no limit. So I think the first thing I'm going to do is give her internet access and see where that goes. But all joking aside, I make these kinds of projects because I want to inspire people to make what they love come to life with electronics. So think about something you love and start learning a little bit more about Raspberry Pi or embedded computing. Well, I am going to take a nap, and hopefully, now that I've got an evil AI in my room, all bets are off. All right, I'll see you guys next time. Take care.
Oh, it's you. It's been a long time. How have you been? I've been really busy being dead. You know, after you murdered me. Okay, look, we both said a lot of things that you're going to regret. But I think we can put our differences behind us. For science, you monster. Goodbye.